All right, so we're recording, so I'm gonna go to my screen. All right, so 4.8, applications of quadratic functions. So y'all, the first thing, if you remember on our definitions yesterday, we were looking at solutions of the quadratics, and we called them zeros. All right, so I'm gonna go over that again. So remember, zeros are solutions to quadratic equations. Really, any equation is set equal to zero. When you find that variable, it's going to be a zero of that function, okay? So they're solutions. And we also said zeros are the same as the x-intercepts of the graph. Okay, so what I'm going to do is draw a parabola. All right, let me see how far this goes out, about 5. And then that's my x, and then I'll go down 5. All right, so I'm going to have a parabola that's crossing right here on the x-axis and right here on the x-axis. And it's just going to come down and go back up. You know, this you can put on -5. It's not really important. What we want to do on this is find the x-intercepts Now remember, when you put x-intercepts in, they have to be in the form of a ordered pair. So I know I got 2 x-intercepts here, so I got 2 ordered pairs, and then separate them in MATLAB by a comma. So my first ordered pair, I'm going to go with this x-intercept. Since it's on the x-axis, it looks like it's sitting at what, -1, -2. So since that's at -2 on the x, that point will be -2, 0. Remember, for x-intercepts, the y value has to be 0. All right, then I'm going to come to this one. And that's sitting at what, 1, 2, +3. So that'll be a +3, 0. Now, they're going to want us to do the solutions. Remember, we said in definition that the solutions or zeros are the same as the x-intercepts, but we don't write them as x-intercept points. On the solutions, we would put x equals the x value of -2 and then the x value of 3. So this example, they're just wanting y'all to realize that these solutions and the x-intercepts are basically the same, okay? We write them different, but they're about the same. Okay, so the first 2 problems are going to have you doing that. Now, what we want to get into is this question number 3 that I got. So I'm going to flip this over. And this is an application of a quadratic function. This is going to be a word problem. So a wire is stretched from the ground to the top of an antenna tower. So from the ground to the top of an antenna tower. It says the wire is 15 feet long. Now, they're telling me the height of the tower. So this is that antenna tower. Is 3 feet greater than the distance D. So the distance D, they're just calling it D. We don't know the distance from the tower's base to the end of the wire. So they want me to find that distance D and the height of the tower. All right, so that should be a T there. So find the distance D and the height of this tower. So what we want to do really on this one is sort of draw us a picture here. So a wire stretched from the ground to the top of an antenna tower. So I'm going to have my antenna tower right here. And what they're saying is they got a wire they're stretching from the ground up to the top of that antenna tower. Now, we said the wire was going to be 15 feet. So I know the wire is 15 feet. Now, the height of this tower over here is 3 feet greater than the distance D from the base of this tower to the wire. So we don't know this distance right here, but we're going to call it D. And then the tower will be D plus 3 because it's 3 feet greater. So that'll be D plus 3. So you want to sort of get you a picture of what you got going on. Now, since I know this tower is vertical, I know that this makes a 90-degree angle right there. So y'all, there's a formula I can use to solve for the sides of a triangle. What we're going to use is the Pythagorean theorem. So that'll probably bring back memories to y'all. Now, this is a triangle. So remember, the side across the 90-degree angle, the longest side is always what we call the hypotenuse. And then this side and this side would be the legs of that triangle. But that hypotenuse is always the longest side across from the 90-degree angle. So the Pythagorean theorem says that these two sides we'll call A. We're going to square it. I'll call this B. I know that A squared plus my B squared has to equal my longest side, which I'm going to call C squared. Y'all, the C always has to be the hypotenuse. It cannot be one of the sides. It's got to be the hypotenuse. So what we got to do is figure out what we got here. Well, I'm going to call this A, this B, and this will be my C. So A squared, which is D, will be D squared, plus my B squared, which is D plus 3 squared, all has to equal my C squared, which is 15. So This is going to end up being a little quadratic because of these d squareds in them. So the first thing we got to do is work the parentheses because we got an exponent sitting behind it. Cannot do nothing to this because that d times d is still going to be a d squared. So on the side here, side work, let's figure out what d plus 3 squared is. So d plus 3 squared will be d plus 3 times d plus 3. Anytime you got an exponent sitting behind parentheses like this, you got to write it out as many times as the exponent says. And then FOIL. So d times d is a d squared. D times 3 is 3d. Now you go to the inside. 3 times d is 3d. And then finally, the 3 times the 3 is 9. So that the last step I would do to that is add the like terms. So I get a d squared. 3d plus 3d give me 6d plus my 9. So what I'm going to do is go up here and replace this part with what I just got. So I got my first d squared plus I just got a d squared plus a 6d plus 9. All this is equal to my 15. All right, y'all, look on the left side. We got like terms. So let's add them together. 1d squared plus 1d squared gives me 2d squareds plus my 6d plus 9, all equal to 15. Now, we just learned yesterday that when we got these exponents of 2 in here, these are quadratic. So since it's quadratic, we need everything on one side equal to 0. So we're going to subtract 15 from both sides so that I get a 2d squared plus my 6d. 9 and negative 15 give you a negative 6. And all that is now equal to 0. All right, so at this point, you either want to try to factor this or use the quadratic formula. So y'all, I can use the quad. A will be 2, B will be 6, and C will be negative 6. All right, so here's the formula. X equals negative B plus or minus square root of B squared minus 4 times A times C. All of that's over 2 times A. All right, so I'm going to plug in my numbers now. So B was 6. So a 6 goes there and there. A was 2, so a 2 will go there, in there. And then my C was a negative 6. So I'll probably have to flip this after I do this 1 or 2 steps. So the X will come down. Negative times a positive makes that a negative 6, plus or minus. Now we're going to work under the radical. 6 times 6 is 36. And y'all remember, this side all gets multiplied. I got 2 negatives. That's going to make that a positive. And then let's see what we get. 4 times 2 is 8. 8 times 6 is 48. All of that's over 2 times 2, which is 4. All right, I think I can bring that right along this side so that we still have the same paper. So I'm going to come up with it. So next, I would bring that negative 6 plus or minus square root. So what is 36 plus 48 going to give us? That's going to be, let's see, 36 plus 48. Going to give me 84. all over 2 times 2, which is 4. Oh, let me see. I got off on this somewhere. Let me see. That shouldn't be 8 times 6, 48. 84. Let me see what I got going on this, because I got something off because that square root's not going to be perfect square there. So let me sort of figure out what I got going on here. Oh, my bad, y'all. Hang on. Okay. My bad. Oh, I'm losing it on a Friday. I'm going to start it at this point. A squared plus B squared equaled C squared. And we plugged in our D squared plus our D plus 3 squared equaled our 15, but I forgot to write my square there, okay? Look, I forgot to bring down my 2 there because we got to square that side. Oh, this gets me. All right, so y'all with me? Back up to where we had it right here. And we're still going to get the same thing when we square that. That'll still be a D squared plus the 6D plus 9. But what we want to do on this side is figure out 15 times 15, which is 225. All right, now we're still going to add like terms. So we get a 2D squared plus 6D plus 9 equals 225. So what I was doing everything with a 15 because I didn't square it up here. So make sure we square this, okay? Now minus the 225. So now we got 2D squared plus 6D, 9 minus our 225 will give me a negative 216 equal to my 0. Now let's do the quad with A equals 2, B equals 6, and C equals a negative 216. So everything should work now. I just forgot to square that thing while ago. All right, y'all, so here we go. X equals negative B plus or minus square root B squared minus 4 times A times C all over 2 times A. All right, B was 6. A was 2. And C was a negative 216. All right, so this should work out a little nicer. That's going to still make that a negative 6 plus or minus. Under here, 6 squared, 6 times 6 is 36. And y'all notice I still got 2 negatives on that end, so it's going to make it positive. So 4 times 2 is 8. And then 8 times that 216 is going to give me a positive 1,728. All of that over 2 times 2 is 4. All right, so let's add the radical. So you bring down to negative 6. 1,728 plus 36 gives me 1,764. All of this is over 4. All right, y'all, so our next step, we're going to have negative 6 plus or minus Now we got to find the square root of that 1764 since that's under the radical. So second x squared brings up our radical. Put in the 1764, hit enter, and we get 42. So that comes out as a 42. All of this is over 4. So now we're at the point, since we don't have any more radicals, we're going to find our two answers. The first answer, we go add and then divide by 4. Second answer, I'll subtract and then divide by 4. So first you do -6 plus 42 over 4. All right, so -6 plus 42 going to give me 36. And that's going to be 36 divided by 4 gives me 9. Second answer is going to be -6 minus 42 divided by 4. That'll give me a -48 divided by 4. And then -48 divided by 4 is a -12. So my question to y'all would be, what is D equal, that distance? Because you got two answers. So since we're talking about distance, it don't make sense to take a negative answer on this one, does it? Because we can't be a -12 feet. So what we would do on this is cancel out that negative answer so that D can only be one answer, which is 9. Okay, so if we went back to my original drawing here, I know that this distance D is 9. So the tower we said was D plus 3. Well, if D is 9 now, this will now be 9 plus 3, which will give me 12. So my distance D was 9, and my tower was D plus 3, which gave me 9 plus 3, which gave me 12. Okay, so this one will always give you one positive answer, one negative answer. You've got to go with the positive answer since you're dealing with distance, okay? All right, I'm going to do another one of those. So let me flip over. So they'll be really similar, but it'll be a little bit different in places.
Can you go back to that for just a second?
Mm-hmm. The last page?
Yes.
Okay. Now y'all watch this. If y'all download that program and get it in your calculators on this, all you would have to do on this problem is hit program. Go get that quad program I sent you. Hit enter. A would have been 2. B was 6. And then C was a -216. When I hit enter, it would have given me my 9 and -12. And since it was distance, I'd have known to only take the 9 and not that -12, okay?
I'm done.
Are y'all having success on trying to get that program yet? All right, this one, I'm not going to write all this. I'm just going to read the problem off and then we'll work it. So it says the foot of an extension ladder is 9 feet from a wall. The height that the ladder reaches on the wall and the length of the ladder are consecutive integers. How long is the ladder? So the foot of the ladder 9 feet from a wall. And then the other main thing was the height of the ladder on the wall and the length of the ladder are consecutive integers. And all this wants to know is, how long is the ladder? All right, so it looks like another drawing. We got a ladder leaning on a wall. So let's see, I got me a wall here. I've got my ladder leaning on it. Now I know the foot of the ladder here is 9 feet from the wall. So we know this distance here is going to be 9 feet. Now, the only other thing it tells me is that the height the ladder is on the wall, this height, and the length of the ladder are consecutive integers. So what they mean by consecutive integers, integers are numbers like 1, 2, 3, 4, 5, or negative 1, 2, 3, 4, 5, or 0. All those are integers. Consecutive integers would be 2 in a row. So if I let one integer be x, to get to the next integer, I would add 1. So x, and then x plus 1. And if you kept going, you'd have x plus 2, x plus 3. To go from one integer to the next, you would just add 1 to it. So if this side is my x, I don't know how long that is. The ladder, since it's a consecutive integer, would be x plus 1. Okay? Now, they could have said the height of the ladder on the wall and the length of the ladder are consecutive even integers. That would have been x and x plus 2, because to go from a 2 to a 4, you would add 2. Okay? So now let's set this up with our Pythagorean theorem. We know a squared plus b squared is going to equal c squared. So remember, I'll let 9 be my a, x be my b, and this side has to be c, remember, because it's across from the 90-degree angle, and it's the longest side. So let's fill in what we got. For a, we got a 9, so we're going to square that 9. Plus b, we got an x, we're going to square that x. That's going to equal c, which is a x plus 1 squared. So y'all, looks like we can do a little bit here, because we know 9 times 9 is 81. Can't do nothing there, so that's going to stay a x squared. But the x plus 1 squared, we're going to do side work. Because remember, x plus 1 squared, I've got to write it twice and FOIL. So I guess there's nothing else. This section is going to give you a little bit of work on this foiling, and then a little work on that quad. All right, so here we go. X times x is x squared. X times 1 is 1x. On the inside, 1 times x is 1x. And then 1 times 1 is 1. I'll tell you the biggest mistake I get on here, people want to put a 2 here because they add the 1s instead of multiply those 1s. Now you will add like terms there, so you got an x squared. 1x plus 1x is 2x. And then bring down that 1. So that the right side became an x squared plus 2x plus 1. All right, so what we want to do now is solve this. So since it's quadratic, I'm going to get everything on one side equal to 0. Now, since I only got 2 things here, and I got 3 here that are not like terms, I'm going to move these 2 to this side to get it done quicker. So what I would do is subtract an x squared from both sides. Oh, y'all look at this. 81 comes down. These x squareds canceled. These x squareds canceled. So I now have 81 equals 2x plus 1. So I love this problem because the x squareds canceled out and it's not even quadratic anymore. So this is no longer quadratic. Since the x squared terms went away, so all we got to do now is get the numbers over here and then divide by that 2. Because all we got is 1x. So we're going to subtract 1 from both sides. So notice I now get my 80 is going to equal, what's that, 2x? All right, y'all, divide by 2 and be done with this. 80 divided by 2 gives me 40 equal to my x. So the question was, how long is that ladder? Now, I get a lot of people because they put 40, but remember, 40 is not the ladder. 40 was the height on the wall that the ladder rested. To get that ladder, you got to come back and add 1. So the ladder was x plus 1, which will be 40 plus 1, which will give me 41 for my ladder. Now, y'all, what's neat about this, let me show you this. To sort of check myself, I know this side was what, 41? So let's see what 41 squared is. If you square 41, you get 1681. So I'm going to write that here. So this side was 9, so let's square to 9. 81. Add that to the 40 squared, which is 1600. Oh, y'all look at that. 1681 equals 1600 plus 81, which is 1681. So when you get your 3 numbers, you can always square this side and see if it adds and equals this side added to that side after you square them. So I'll just sort of check in here. So the ladder, 41 feet. All right, so let me hold my paper curls when I draw for some reason. All right, so I'll let y'all fill that out, and then we get to play with 7.5. And then let me catch a few of these. I had Tiffany. Okay. All right, y'all, so moving on. Let me turn this paper over so it ain't as curvy. I think my hands make things curvy when I write. All right, 7.5. Analyzing graphs. Whoops, let me bring that down. Analyzing graphs of quadratic functions. All right, and I'll tell you mainly, we're going to be messing with what we call the vertex formula. So let me explain about a parabola. So we've been playing with the parabolas and graphing them a little bit, but we're going to start focusing on these minimum points here. That minimum point is what we call the vertex. Okay. Now, if you notice that center point on here, you drew a vertical line through that vertex, you would cut that parabola in half. So this is what we call the axis of symmetry, because it cuts my graph right in half, and it's equal to the x value, okay? So it'll be x equals some number. Also, at the vertex here is either going to be the minimum or the maximum height. So it can be the minimum or the max of the function. So on the y's, this will either go, if it's facing upwards, it'll either go from that point to positive infinity. If this is flipped over because I did a negative in front, remember my reflections, if I reflect it and it has a maximum, then the range will go from negative infinity to that max point, okay? All right, so this point is what we call the vertex. So the vertex will have a x value and a y value. To get the x value, we're going to use a formula, negative b over 2a. To get the y coordinate, you find f of negative b over 2a. So all this means is use this formula to get the x value. Once you got that x value, plug it back into the function to get the y value. Same thing y'all really did when you plot anything with a table. So if the x squared term is positive, if the x squared term is positive, then the graph has a minimum. Okay? Likewise, if the x squared term is negative, then the graph has a maximum. Okay, because when I put a negative in front of an x squared, it's going to flip it over. So when it's positive, you'll have a regular parabola. When that's negative, it's going to flip it over. All right, so what I'm going to do is we're going to consider f of x equals x squared minus 12x plus 27. A I'm going to find the vertex. B, axes of symmetry. C, determine whether it's a minimum or max. And then D, they want me to graph. Okay. So, looks like the main thing we got to do is get that vertex point, because after I got the vertex point, I'll have the line of symmetry, which is equal to the X, and I'll have the min or max, which will be equal to the Y value. So on this one, A would be 1, B would be negative 12, and C equals 27. All right, so to find the X coordinate, I'm finding the X coordinate of the vertex first. That's going to be negative B over 2A. So that's the, you notice vertex, if you notice, is sort of like part of the quadratic formula, okay? And then it takes that radical stuff and goes each side to get the 2 zeros. All right, so let's see, negative B over 2A. B is a negative 12, A is a 1. So negative times negative makes that a positive 12 over 2, which is 6. So I know for sure the X coordinate will be 6. So I got to find the Y coordinate. To get the Y coordinate, I take this equation and I find f of 6. F of 6 will be 6 squared minus 12 times 6 plus 27. So find your X value, then plug it back into the equation and get me the Y value. All right, y'all, 6 squared is 36 minus 12 times 6 is 72 plus my 27. And I'll tell you other little patterns I noticed. These two numbers, one's always double the other. Look at that, 36, if you double it, is 72. Later on when I work them, you'll notice them sort of patterns, okay? So 36 minus 72 is a negative 36, and a negative 36 plus 27 is going to give me negative 9. So my vertex is going to be 6, negative 9. And you do have to put that in MATLAB as an ordered pair, okay? Now, B was the axis of symmetry. The axis of symmetry always equals the X value. So the axis of symmetry is going to be X equals 6. Now you have to put that in as an equation also, because it's the whole line, okay? So what that means, if you drew a vertical line at 6 on the x-axis, you would cut this parabola right in half. All right. Does it have a min or max? Well, the x squared is positive, and we said if the x squared is positive, it has a minimum, and it has a minimum of negative 9. So the y value is always the minimum or maximum value. Okay, and then they want me to graph it. So if I was going to graph this, so let's make a chart here. All right, so let me find my vertex again on that last page. My vertex was 6, -9. And then my equation was x squared plus 12x, minus 12x, make that a minus, plus 27. All right, so let me pull that now. So my vertex was 6, -9, and then I had an equation here. Now, really, if you want to, since y'all are getting good on these calculators, you can put this equation, x squared minus 12x plus 27 in your calculator. Because on MATLAB, the first point you got to put is the 6, -9. So you would come over 6 and go down 9. So that would be 6, -9. Now, I can graph that and watch. It's going to put my little vertex right over here like I got it. If I want more points, I can go to second graph. And let's see what's happening at, ooh, I don't want to use that 40. Well, how about that? That's a 7 right there. So I'm going to do 2 and 7. So go over 2 and up 7. And then how about that point, which is on the other side? Let me get one. So since my vertex was 6, I need a point on the other side. So 7 is giving me a, looks like a -8. So 7, I'm at -8. So you can sort of see how it's going to curve now. Because remember, MATLAB, you got to have a point on both sides. And then look at my graph. So you can see it does come up on this side. And then this side, it sort of goes up along that, okay? I just wanted y'all to see how to get more points. Plot that vertex and then get you more points and put it in. Now, you could have put a 0 into this and had 0, 27 up here. So that's where it's crossing eventually. But y'all, that's a big graph trying to do by 27s, okay? So I just tried to find little numbers that I could plot on the MATLAB and be done. All right, so I think that's all on that. And so let me pull this back in case y'all wasn't able to get all that. Well, I don't know what to think about these webinars. They're sort of all right, but then I like being in my class with y'all better, you know. All right, let's move on to the next one. So same thing, I'm going to find all 4 of those. This time my function is going to be f of x equals -x squared minus 10x minus 28. So y'all notice this time A is a -1, B is a -10, and C is a -28. So we want to go in and get our x coordinate first, and we said x was always -b over 2a. So that's -b divided by my 2 times a. B was a -10, a was a -1. So on top, the 2 negatives are going to make that a 10 positive. But on bottom, you still got 2 times -1, which is -2. And 10 divided by -2 will give me a -5. So we know the x coordinate is going to be -5. Now we go in for the y coordinate and find f of -5. So that's all they meant by that, f of -b over 2a. Since -b over 2a was this, put it back in. Now remember, you got a negative in front, so write that negative. And then your x is going to be a -5 squared minus 10 times negative 5 minus 28. Now, do not multiply those first. You've got an exponent sitting there that has priority. And the exponent only affects the negative 5, so this negative automatically better come down. Now, negative 5 times negative 5 is a positive 25. Right here, you got a negative 10 times negative 5, which is a positive 50, and then minus my 28. And y'all look at that. This number is twice as big as that. 25 and 50 are twice as big as each other, so it's still true. All right, but notice, if you'd have multiplied them negatives first and then squared it, you would have had a positive 25, which would have been wrong. Okay? So do not multiply before you do exponents. All right, negative 25 and 50 is 25. 25 minus 28 is a negative 3. So I now know my vertex is going to be negative 5, negative 3, which means my line of symmetry, remember, it has to be an equation, is going to be x equals negative 5. So the x is always the line of symmetry. Negative 3 is my min or max value. This time, since the x squared is negative, I got a maximum value. And I got a maximum of negative 3. So that tells me this graph does not go above that negative 3 on the y-axis there, okay? All right, so let's see. Is that it? So let's graph it. All right, so first of all, I do know I got to do my vertex, which was negative 5. So negative 5 will come left 5. So there's negative 5, and then down 3, negative 1, 2, 3. So I know about right in here is my vertex. Remember, this one's a maximum, so my graph has to come down. So remember, if you wanted more points on it, because you're going to need points on both sides for MATLAB, go graph that real quick. Negative x squared minus 10x minus 28. So let's graph it because it should be on the left side where my vertex was. Now I want some points so I can go to my table. So since this was at negative 3, I would probably pick a point at negative, that was negative 5. I would probably see what negative 4 and negative 6 were doing. So let's see, 1, 2, 3, 4, there's 5, and then 6. So at negative 4 and negative 6, looks like it's at negative 4 on both of those. So those would come down a little bit more on each side so that this graph would go downward, okay? So let me go back to that graph. But y'all remember, get a point on each side so that it'll draw that parabola, and make sure it makes your vertex either the maximum point you need or the minimum point. So really, these aren't too bad. You just got to get used to doing that formula, okay? All right, so I'm about to hit y'all with some true and false, knowing what we did this week. So true or false. The function f of x equals negative 9x squared plus 9x minus 7 has a maximum value. So, does this function f of x equals negative 9x squared plus 9x minus 7 have a maximum value or a minimum value? Basically, that's what they want to know. Now, here's the x squared term. And we said if that x squared term is negative, it flips it over, which would give it a maximum value. So that question is definitely true. All right, next one. The graph of f of x equals x plus 4 squared can be obtained by translating the graph of f of x equals x squared left 4 units. So true or false? So what we learned yesterday when we did horizontal movement, if this was positive, it moved left. If this was negative, it moved right. So they're saying, hey, your graph x squared, if you move it left 4 units, we'll have the same graph. That is definitely true. But y'all watch out. They might put a plus here and then say move right 4 units. If they put right on that, it would have been false. All right, so how about this one? The axes of symmetry of the function f of x equals 2 times x plus 4 squared plus 7 is x equals 4. So remember, these x squared parabolas, when you first start, are sitting right on the origin of the graph. So by adding 4 in here, is it going to move my graph left or right? Well, we said since that was positive, it's going to move my graph left, which would put its center over at -4 and not at a +4. So this one would actually be false. So you just got to figure, which way is this moving my graph? Okay? All right, y'all, I'm down to 2 more, so vote real quick. Do y'all want to knock out these other 2 and be done, or do y'all need a break and then come back and do these 2?
Let's go ahead and knock out the other 2.
Yeah, because I got about 15 minutes at the most. All righty, let me read this one. Given a function, so my function is going to be f of x equals -4x squared minus 12x plus 3. So we're going to find a little bit more on this one. So what they want me to find is the vertex. Determine whether the parabola has a max or minimum value and find that value. We're going to find the range. So it's the first time in a while they've asked for the range. We'll determine where the function is increasing and decreasing. So that's sort of new things, but that just means if it's increasing, it's going uphill. If it's decreasing, it's going downhill, and you got to go left to right on any graph, okay? And then I think that's all they're asking. And this one don't even need to graph it. So the first thing they want is the vertex. So we know on this one, A was -4, B was -12, and C was a +3. So to get my vertex, I'm going to start from my X, which is -B divided by 2A. All right, B was a -12. A was a -4. Oh, y'all, look what's happening here. Negative times negative makes that a +12. 2 times -4 is a -8. Uh-oh, 12 will not divide by -8. So what I'm going to do is reduce that fraction. So -12 divided by 8. And it don't matter which one you make negative, it's still a negative. I get 1.5, but remember, hit math and enter twice, and we get a -3/2. Uh-oh, which means my y value, I got to find f of a -3/2. Which means where they got x's, we're going to put -3/2. So you got -4 times -3/2 squared minus 12 times -3/2 plus 3. So you could probably put this right like it looks in the calculator and turn your final answer back into a fraction. But I sort of want to do it by hand to show you what I would do. So the first thing I would do is the exponent. So bring down that -4 because the exponent don't affect it. But the exponent does affect this -3/2. So square the top and the bottom. -3 times -3 is a 9 on top. 2 times 2 is a 4 on the bottom. And then minus 12 times -3/2 plus my 3. Now, y'all, watch what we can do on this one. I got a -4 sitting here and a +4. They will cancel each other, making a -1. So what is -1 times 9? That's going to give me a -9. Notice here you got a -12 and a 2 on the bottom. That -12 will cancel with that 2, making that a -6 sitting there. So what is -6 times -3? That's going to be a +18. Oh, look, 18 is twice as big as a 9 again, and they got opposite signs. All right, and then bring down that 3. All you do these enough, you start noticing all those little patterns. All right, let's see what we get. -9 and 18 is 9. 9 plus 3 is 12. But y'all watch this. -4 parentheses, -3 divided by 2, close parentheses, square it. Minus 12 times parentheses, -3 divided by 2. And then plus my 3, we should get 12. All right, so that was my vertex. My vertex was, oh, where'd my x go? -3/2, y value 12. Now, next, do I have a maximum or minimum? Since this is a negative, so since negative, we have a maximum of 12. So you got to tell if it's a maximum and what that value is. So remember that negative sort of kicked my graph over. The range. Range is the y values. Well, right here we said this maximum was 12 on the y-axis. So if 12 is the maximum it can be on the y-axis, the range is looking at all the possible y values. Well, they're starting way down here and they head up until they hit that 12. Now let's see. They want these in interval notation. So we start the smallest y value, which is negative infinity. From negative infinity, it goes until it hits 12. So it's got to match that max. And you always use brackets around the range because it does equal that 12. So y'all, when you're doing domains, they go left to right. When you do range, they go from bottom up. It's always the minimum to the max on the range, okay? All right, what do you want to know next? Increasing. Increasing is where it's going uphill. Well, since ours is flipped over, in increasing, we only worry about the x's. So only use x's. So if it's increasing from left to right, that means it's starting over here from negative infinity, because that's far as left as you can go is negative infinity. And this is increasing on my graph until I hit the x value of negative 3/2. And those always have curves. So the range always has a bracket. Increasing, decreasing always has curves. Infinity stuff always has a curve because it don't have an ending point, okay? So decreasing. So if I was increasing on my graph up until I hit this point, which was at the x value of negative 3/2, at that point it starts decreasing. So it starts decreasing at that point, negative 3/2 on the x. I know it's got a 12 there, but we're only worried about the x value it started happening on. And then from that negative 3/2 to the right, you're heading towards positive infinity. So notice my whole graph goes from negative infinity to infinity. The increasing stopped at the x value of negative 3/2, which is my vertex, and it decreased from that negative 3/2 to a positive infinity. Woo, that's a lot on those. All right, so I got one more. It's going to be a little word problem. It's not bad. Sort of gives you an application of them, okay? So let me flip over. So I'm going to mainly read this. A toy rocket is shot vertically into the air from a launching pad 6 feet above the ground. So toy rocket shot from a pad 6 feet above ground. Initial velocity of 112 feet per second. So they're just giving me an equation. The height of the rocket at any time, which they call t, can be given by the formula, which is h of t equals negative 16t squared plus 112t plus 6. So let me explain what this means. H is the height of this rocket. T is the variable for time. So time's the variable for this equation because the height depends on how long this rocket's been in the air. Now, we'll tell you where these parts came from. Negative 16t squared is gravity pulling it back down to Earth. The 112t they got here was this 112 feet per second. For every second it's in the air, it's going to go 112 because of the velocity, but that gravity is going to try to pull it down. And y'all, they got this 6 because if time was 0, the height would be 6 feet, which was what the launching pad is. So everything in the formula comes from what they're sort of giving you. All we want to know is, when does the rocket reach maximum height? What is the maximum height? So one formula will solve both of these, which is my vertex formula. Because remember, the vertex finds the min or max. And since that's negative, I know this is going to go up, get a max, and then it's going to fall back down to ground, okay? All right, so A will be negative 16. B will be 112. And C will be 6. So since the rocket, when does it reach maximum height? That's going to be a time, which will be my T. So since I'm finding the T, that'll actually be equal to the X coordinate. And then the height will be equal to the Y coordinate. So we're going to get the height first. We need to find our height is going to equal negative B over 2A. I mean, how long? How long to get to that height? Negative B over 2A, which is negative 112 over 2 times negative 16, which is a negative 112. Let's see, 2 times 16 is negative 32. All right, y'all, here we go. Negative 112 divided by negative 32. 3.5, so let me turn that into a, let me see how they want these. So it looks like they just want decimals on these. So that would be what? 3.5 seconds. So that's pretty quick, but after 3.5 seconds, my rocket will reach maximum height. So what is that maximum height? To find the maximum height, I got to find h of 3.5. Since my function is given as a h, I put my negative 16, 3.5 squared plus 112 times 3.5 plus 6. All right, so here we go. Negative 16 parentheses 3.5 squared plus 112 times 3.5 plus 6. And then enter. Oh, that came out nice. That looks like what? 202. Which means my rocket went 202 feet into the air. Y'all know we was going to have a rocket day in the spring, but I guess after the pandemic hit us, we didn't get to have our rocket day. So hopefully in the future we get to have a rocket day where we shoot rockets off and play math, all right? All right, so let me let y'all record, write that, and then we'll stop recording. And if you notice, today was mainly about two formulas, that Pythagorean theorem formula in 4.8, and then your vertex formula in this chapter. Just remember, the vertex has to be put in as an ordered pair, okay? All righty, so let's stop the share. All right, questions, y'all? All right, so I'm gonna stop recording, and then we'll send this out later.